We're going to do some more practice with the properties of logarithms here. So just a quick reminder, the product property is log base b of xy equals log base b of x plus log base b of y. And you can read that backwards or forwards. The quotient property is log base b of x over y is equal to log base b of x minus log base b of y. And again, you can read that backwards or forward. And the power property is log base b of x to the power y is equal to y times log base b of x. And again, you can read that one backward or forward as well. Okay, so the first thing we're going to be doing is using the properties of logarithms to condense the expression into a single logarithm, and then we will be simplifying this time if possible. So this one, I've got a log base 3 of something minus a log base 3 of something. So because it's a log minus a log, I can use the quotient property. So I'm going to start with that. That means it'd be log base 3 of the first expression there. So 2x to the fourth minus 3x cubed minus 9x squared over 2x plus 3. Now I do want to simplify this if possible. This rational expression that is the argument of the logarithm here has a numerator that could be factored. At a glance, I see that all of the terms that are up there have an x squared in common. So I'm going to start by factoring out an x squared. That would give me 2x squared minus 3x minus 9 over 2x plus 3 still. Okay, now 2x squared minus 3x minus 9 is a quadratic expression, which can probably be factored as well. So to see if it could be factored, I'm going to multiply the a and the c together. So 2 times negative 9 is negative 18. And if there are numbers that will multiply together to make a negative 18 and add to make a negative 3, then that means that that will factor. And those numbers do exist, so that means it will factor. That would be a negative 6 and a positive 3. So I'll go ahead and set it up for factoring. I've got 2x times x to make that 2x squared. Then my outside product, 2x times a negative 3 would give me that negative 6. And then a 1 times a positive 3, so plus 3 here, would give me the positive 3. Okay, so now I can see that I do have a factor in the numerator and the denominator that could cancel. So that 2x minus 3 I can cross out. That'll leave me with just log base 3 of x squared times x minus 3. Now this is condensed into a single logarithmic expression, which is what they told me to do. And there's nothing more I can do to simplify in there. So that one is done. We'll do one more like that before we move on to the practice problems. Okay, so again, I'm supposed to condense this into a single logarithmic expression. This one has some numbers in front of the logarithms. Those numbers in front of the logarithms are going to become powers. So I'm going to start by saying log base 5 of x minus 1 cubed plus log base 5 of x plus 1 squared minus log base 5 of x squared minus 1 squared. Now I can condense these using the product property and the quotient property. So this would be log base 5 of x minus 1 cubed. This is plus another logarithm, so that's going to be multiplying. So times x plus 1 squared. And then it says minus the logarithm, so that one's going to be divided by. So on the bottom I would have x squared minus 1 squared. Now hopefully you're looking at that denominator, that x squared minus 1, and you're thinking, well, that's factorable. I know that that's a difference of squares, so I'm going to be able to factor that. So I'm going to recopy the numerator here. And then I'm going to factor the denominator. Now it says I'm supposed to have x minus 1 squared. So when I factor that, it would give me x minus 1 times x plus 1. But because the whole thing was squared, that means each of those factors would actually occur twice. Now I can look for common factors in the numerators and the denominators that I can cross out. So I see that x minus 1 occurs in both places. There are 3 of them in the numerator and 2 of them in the denominator. So that means I could cross out 2 of them total, and that would leave 1 behind in the numerator. With the x plus 1s, there's an x plus 1 squared in both the top and the bottom. So those are going to cancel out completely. When you divide those, they make a 1. So all that's left then is just log base 5 of x minus 1. That's now condensed into a single logarithmic expression, and the argument of the logarithm cannot be simplified any further, so that's as far as it goes. Now you do the next couple problems on the Google form.